Okay, so we just looked at the idea of the work energy theorem and that the network acting on the object changes its kinetic energy. So let's use our intuition about sort of things that we're familiar with to play with that idea in terms of a conceptual way, and then check it with the math that's related. Okay, so you know on exit ramps, they have those barriers that if you miss the exit ramp, you can hit a barrier and you won't get into a major accident. Well, exit barriers, they have about 50 meters to bring a vehicle to a stop. So let's imagine that we have two vehicles that are going to cover that 50 meters to come to a stop. One vehicle is moving at 20 meters per second and coming to a stop, so 20 meters per second to 0 meters per second, and the other is going 40 meters per second and coming to a stop. If they come to the stop in that same amount of distance, which one is going to experience less force? Well, intuitively, you would probably say the car moving with less speed. It's easier to stop a car that's moving slower, and so it will take less force. It's easier to stop that car. So intuitively, we understand the work energy theorem. But does that work in terms of the mathematical representation of the work energy theorem and what we've been talking about? So the work energy theorem, remember, is that the network is equal to the change in kinetic energy. Now for the case of the car moving at 40 meters per second coming to 0, or the car moving at 20 meters per second coming to 0, the car moving at 40 meters per second has a much higher change in its kinetic energy. If it has a higher change in kinetic energy, it has to have a much higher work done on it. And so we also want to remember that the network is also equivalent to that net force times the distance. And if it's moving in the same plane, we don't have to worry about the angle, the parallel component, the net force acting on that object through that distance. So both of these objects cover a same distance of 50 meters. And since it takes so much more work to change the car moving 40 meters per second than it does at 20 meters per second, that must be done by a much larger force. So yes, it is easier to stop a car moving at 20 meters per second. So our intuitions and our physics are matching. All right, we'll do some practice problems with the work energy theorem also. This is sort of bringing that conceptual idea and confirming it with what we know mathematically. Good job.